let the pie touch your point. I really like emoticons, riddles, kind of things. It's not a riddle. This is the next one. This is the whole lecture in one riddle. It's going to be about snakes, Python, square root maybe, about you behind your computer, about drawing, and about mastery, like who becoming the master in something. But I want to make the introduction of the lecture based on what David Jonathan Ross said in Porto three weeks ago. He was speaking about the material of type and type design. So I want to go very quickly through history of type. So this is an R. This is a beautiful R. It's carved 15 years ago by myself at Type Media. I'm super proud of it. I made one character. Yeah. The thing with stone carving is that you need a chisel, you need a hammer, and you take stone away. What you see, there is no black, there is no white, there is only light and shadows. There's highlights, and based on the time of the day, you see like a different kind of version. You never see the full R. It's always like parts of it. So the material in this case, and was for a long time, was stone and light. The thing that you see reflects shadows and highlights, which is kind of like a cool thing, because there is no black, there is no shape itself. It's only like something which is carved out of material that you get out of the stone. Through time, this is a picture I took in Palermo. If you can carve multiple letters, which I'm not able to do, then you can also just do whatever you like. You can put two different kind of R's in there. You can put like a ligature because it doesn't fit. Oh, we have to squeeze in the T. Squeeze it in. And this is kind of really cool. It happens and it's possible. It's only possible because there is someone carving and I'm at the C and the A and then like, oh no, it's not going to work and you have to fit in. And this happens. And this is really cool. And it's also very graphic in a way because this is possible. Nowadays we just like squeeze in and we scale down and we don't have this kind of like mistakes, or maybe it's not a mistake, but it has to be there. So this is kind of a cool thing. Another kind of I'm making big steps in history. LED type. This is used as block print, so the ink is on top. Paper is going up on the metal, on the ink, and the press is going down, and the ink is on the paper suddenly. These kind of LED blocks with letters on it are made first of all with a punch. A punch is a steel kind of device that you engraved and file away with a file. And then you strike it into a matrix, and in the matrix you just like cast out a LED type out of it, which is kind of really cool. But then you also get something like this. This is from a presentation that Fred Smeyers did at ISType in Antwerp last September. And he's calling this the tap dancing P, because the T is tap dancing. It's 6 points from Pierre Holtin. And it clearly shows Fred's point of his book, Counterpunch, that engravers used a counter punch, a different punch for doing the counter as from the outside of the character. But Pierre Holtin, he knew what he was doing. He was able to carve really nicely, but also he wants to be really fast because he had to carve multiple punches a day to get a living out of it. So that's why the P is like a very swappy kind of leg. But he also knew when he was printing this on bad paper or vellum, it'd be printed with a press, it would be like a nice straight kind of line. So it doesn't really matter. And it's really cool that he and other kind of engravers they were focusing on the purpose, on the size that they are using it. So now we are looking at this P, which is like almost 2 meters high. It's only like 6 points. It's like really, really small. And maybe also you have to try to file like a little thing away with a punch. It's really hard, and then strike it, then you get something like this. Other kind of things, when it becomes like a graphic element. So this is a Bodoni from the Bodoni Museum in Parma, where the serifs all get like little dots, which is kind of like a super nice graphic element, but it's also a very technical element, because if it was removed, the serifs were too sharp, and it will like break off while you first engrave it or punch it into a matrix or strike it into a matrix and cast lead out of it, and when you put it on a press, it will just break off. And so that's why you need extra kind of material. The cool thing about lead type, so the material of lead type is that you would just carve something away from a steel punch, and that you have like steel that is really impressed into the paper. And because of that, and because people who were engraving, they knew all this kind of stuff. So they were able to manipulate and change the shape of the letters towards a process that we'll be using. I'm jumping 300, 400 years, 300 years to, this is a silly ad for Father's Day. That was like last week. So I didn't get one for my son and my daughter, but maybe for 8 I really want to have. It contains 1 or 2 or 3, maybe 4 typefaces. Photo typesetting was something that you would draw or you would cut out of kind of like plastic material. It would be kind of scaled down and put on a disk, and then light is put through that disk. It would like rotate inside the machine, and it would be being projected on a photo sensitive plate, and then from there it will be printed. This is the first time that everything is scalable. So you have like one master, one drawing, one plate for doing the 6-point, but also for really big sizes, which is kind of like a really cool kind of thing. So this is a master for a Neue Helvetica. Already you see like cool thing happening that there is kind of like a light trap, because it has to be sharp, because the designer who did the cutting for this Neue Helvetica, he knew about photo typesetting, he knew about light, and he understood that maybe there should be something extra light in there to make the corners really, really sharp, which is really cool. Because you could not do this in stone, you could not do this in lead or with punches, but you can only do this with photo typesetting. Another kind of cool thing is that you can, this is an ad for ISType, which is it was something that producing, this was the technology of Berthold producing this kind of discs, that you can also just, because it was light, you can just put like a different kind of lens in between, and you can add distortion, you can have filters, you can mix up spacing and kerning, and you just can do whatever. It was kind of the first time that this happens, because it was just something which is detached physically from from the thing which is printed on the paper, but also there is light in between. So the material of this is light, but also the lens. The lens is in this case really, really important. So you can question yourself, what is this shape, which is a digital shape? What is the material of it? Where does it exist out of? It's scalable. You can just like have multiple purpose. You can print it with an offset. You can also print it on a billboard, really big. It can be a cap, can be on a bag, can be on your shoes, can be anywhere. But what is the material made of? If you look at how tools are looking at it, it's a series of dots that connect. But even the dots, they connect, and they have like a curve or something that goes from one point to another point. This is also kind of a generated kind of thing. So the curve itself, these little lines, they don't exist. They are just there because they are calculated. It's a generated kind of thing. If we dive into what a curve actually is, we have two kind of curves in this new kind of digital world. One is a cubic curve, which was invented by Pierre Berger somewhere in the 60s. In the 60s, you get like these cars, because it was invented for Renault to describe the bodywork of. So you have to imagine that you're a mathematician and you have to drive this car, and you're like, wow, cool. Or this car, like, oh, seaside in Nice. Wow. All right, so this is the car. And what happens is that the math is actually very, very, very clear. So we have to calculate the curve and how the curve is working. So it's always going to take like 50% of everything. So we have 2 dots, and we have the half of it. This is a dot there. We have 50% there. The half of it is also kind of another dot. We connect the off-curve points, and there is a dot there. If we connect all these dots again, and we have, again, there half of it again, and half of it again is a point on the curve. This is how a curve has been generated. So you can also not taking half of it, but also 10%, and then going from 0% until 100% at the end. This is how the curve has been generated. The cool thing, if I just go back like a little bit, is that what happens if you visualize the whole big curve is that the small curve, which is in here, like this one, is again a cubic curve again, which is kind of like a cool thing because you just kind of subdivide the whole kind of thing. So this was the animation. Okay, move, boom. The other kind of curve that we know of is a quadratic curve. Quadratic curve came along in the digital world because there was kind of a thing between Adobe, Apple, and Microsoft, and they would not share, and it's my thing, it's not your thing, and we're going to make something else. Stupid fight. It's better to share and to talk about, and this is what's happening now. But back then we have quadratics. The idea is that it comes from making boats and making a bend into woods and to making airplanes. So you have these dots or things that you can fixate, and then you have a piece of plywood that you just can curve around this kind of dots. It's also very popular and used to calculate the curve of wings of airplanes. So you have to have this in mind. So the same kind of thing is happening for quadratic curves. You have the half of it, another half of it, have the half of it, and this is again a point on the curve. The cool thing is here also this smaller curve, this one, is also kind of, again, a curve. It's like a subdivision of the big curves, which is kind of a cool thing. So this is then again a point on the curve, and then the whole thing animated. So if you don't see, or we don't design, or the material is not the curve because the curve is generated, so what do we see? It's like a galaxy of points. Like, I'm going there. Look, where are you? I don't know. Maybe it's not really a galaxy of points, but it's like a set of data which are points and numbers that we just are using to give an action, a drawing action, how to draw this kind of characters. So the whole kind of thing, this black shape, this G, exists out of placing points, but also the points represent the border. And this is the first time, like in type history, if you think about it, that we don't carve away something. There is no material which is going to be black. You don't draw it. You don't fill the inside. You don't draw the black. You always draw the border. It's always drawing this line. The thing is, with digital type, you don't fill this kind of shape. In your head, you're doing this because this is the enclosed shape of the drawing of the border, but like with stone, you get something out of it. With a file and steel punches, you also get something out of it. But even with phototype setting, you have a very precise drawing or a cutting, and it's not always about the border. And here it's very strictly about the border, where the white becomes the black and vice versa. And you actually never designed what is really black. You designed the border, which is kind of like a really kind of thing, really weird thing. So type design nowadays, it's not about stone, steel, maybe some drawing, but a lot about numbers, and actually numbers plus something, plus math, and actually there is more math than only numbers. So if we think about kerning, open type features, we think about interpolations, variable fonts, it's like a lot of math that happens on top of your numbers, that you design. This is an exercise I'm doing a few times with my students in about point placement, because where you put your points, where do you put your border, and how do you mark your border becomes really important, because everything in between is calculated and becomes really, really, really important. And actually it becomes more important because, like now with variable fonts, you ship everything in between. This is what you give access to graphic designers, to web designers, in how these kind of things behave. So it's not only about placing points, but also how points behave and where are you going to. This is like really important, and I think it's really important that you also do research on point placement, because we are learning point placement from all hinting kind of area kind of thing, but maybe it should also be maybe different. Is a square really a square, or could be the points on a different kind of placement? So I think it's a really fun exercise, because they also do like a little bit of coding, which I'll come back later, but also about point placement and seeing how things behave differently when you just place points on a different kind of position. Not to make errors, but also just to make like decent kind of typefaces in between and make them different again. All right, if you look back at the original kind of thing, so we have the dots, we have the curves in between, and what tools are doing nowadays, they are just like giving instructions to, with a mouse device kind of thing, through your elbow, your wrist, and your hand. Your brain is telling you move it, and then you're moving, you're clicking, and then you're shifting a point. This is what is really happening. So we are all now masters in moving a mouse. It's not going to, you cannot win like a war, like with swords fighting or something with it, but you're, I don't know, you win something, but we are masters in moving the mouse. I think maybe that's not enough, because we have a set of actions, and we fill and we change the variables in this kind of actions. So interfaces, UIs, really is really important in how we perceive kind of things and how we can move and see things happening on screen. And I don't only want to be a master in moving the mouse, because I don't really care about this kind of little thing. I care about the end result, about how shapes looks like and how they can communicate with different kind of things. All right, same curve, but we're going to look at a different kind of thing. Every action, every curve is actually a sequence of instructions, actions. So first we have to think about like a very physical kind of thing. You move your pen and you move it down to an XY position. Then we're going to curve it to a specific kind of position with off-curve and on-curve points. So that makes the curves itself. It's a set of actions. This is happening for every kind of little segments inside the whole kind of shape. If you're looking more at the graphic design kind of thing, this is the same kind of thing. It's a little bit more complex because you have more variables. But we have, for drawing a rectangle on the screen, we have an X height, so X and Y value where we start, and then we have a width and a height, and we give it a color and this kind of stuff. But every little thing is a variable. So we are now designing with our mouse in our hand, looking at the screen, we are designing the variables and changing the variables inside actions that we predefined before. So if you move a point and then you just like changing the variable like a little bit. I think this is kind of dangerous, just to trust the mouse and your head and your elbow. So maybe what happens if you break your arm, then you try to learn it with your left hand, and then it's not working out, doesn't just Right. Coding helps you. But in a way, coding is like scary. The thing is that everything here on screen, it's all digital kind of tools. I just unplugged. I've just plugged in my device because it needs some kind of electricity somehow. But this kind of things, this kind of instructions with a tool becomes the pen, the chisel, the file, the punch that we are using. And the material is the numbers. How can we master this kind of numbers and be kind of the chisel is to do with coding. I think we all have to go and do coding and to learn how to embrace kind of coding inside kind of a design kind of environment. when we're looking at the material of stone carving and engraving and steel, there is kind of like a very close relationship between craft, making it, and the design of it, how it looks like. Nowadays, there is kind of a bridge, there is a cut between craft and what we're doing and what we are seeing and what we are designing. We are not learning everything from this computer and what it can do before we can do designing. It's kind of like somewhere in the kind of between. There is kind of a clear bridge. While if you cannot carve in stone, you cannot carve an R. It took me like 3-4 days to carve that R. So we first have to learn what is a straight line, what is a curve, to even just start to do something that looks like an R. I think this is a sad thing. I think this is not a good thing, that there is kind of this really big division between craft and design. Between making and creating. I think creating is always making, and be critical, and while you're making, you're also creating, and you're also designing, and then you're also doing the craftsmanship while you're making and while you are creating. The how we are making it, and the why we are making and why we are doing something kind of design, which is what's the brief, how we are going to do this kind of stuff, is becoming really important. And it's really important that they are also becoming more closer to each other, even in kind of a very kind of digital environment. If they are kind of too much separated, then you can just like ask someone else to do it. And then maybe the design, you will never make a tap dancing P or like a very weird kind of ligature because you didn't know how it was being made, and the guy who is making it will never know why it's been made. And I think the same person, that's also what I see with students, it's really difficult, and better students, they get better when the how and the why are coming closer together. So, okay, what is the craft of coding and how can we learn this? Because this is a scary kind of thing, because it's about bits and bytes and ones and zeros, and it has nothing to do with beautiful letters that we all want to draw. But first thing is that we're using Python. I'm using Python. A lot of type designers are using Python. Python is a very popular kind of language. It has a high learning curve. It's a high-level programming language, meaning that it doesn't have to deal anything with ones and zeros. You don't have to really go into the bytes of the program and change something. You can read it. So this is a very small example of a Python code. So we have a variable a, we put 10 in this a, we're going to print a formula out of it, and then it will show you a number. We're making a list. The list has 3 items. You can loop over every item in that list, and then we just can print it out. Very simple kind of, a simplified kind of program, but you can read this, and this is really important in the Python kind of world, that we can also read it while we kind of, us like designers that we are. So Python is a programming language which is very close to a human language, how we can speak about, but the only thing is we have to use the correct words. There is no kind of other kind of thing. Building on top of Python, craft of coding can be learned with, for example, Drawvolt. Drawvolt is an application that I'm doing together with Just van Rossum in the back. I took over like a little bit of the project, but we're still kind of doing kind of things together with Drawvolt. And the first goal was to have Drawvolt as an educational kind of tool. How can we learn graphic designers, type designers, how to do coding? So there's kind of a very graphical interface, and you can have like a direct kind of thing, or for what you see is what you get kind of thing. It's written in Python itself, it's open source, it's free, everyone can use it everywhere in the world. I'm using it to teach, Just is using it to teach, and a lot of people are also using to teach. The cool thing is that Drawvolt also became like a utility for us to make things. It's for us a replacement of InDesign. We can make things which are not possible in InDesign or other kind of tools because we can just make our own kind of tools. So this is how the interface looks like. So we have an area where we just can type the program. So this is a simple rectangle. We have an output window, and then we have a drawing part. And in that drawing part, we're just going to draw a rectangle. Very clear, it's readable, and then you just have to know the word rect And then the rectangle has an X, Y, and a width and a height value in there. It's always cool because this is a very simple kind of small kind of thing, but the smallest program are most of the time the best. This is the same curve as we did before, so we set the size of the page. We're going to create a new path. We're going to move our pen to a specific position. Then we're going to curve to off-curve points and to point where we are curving to. We're going to select the stroke. This is the same thing as what happens in InDesign when you go to colors and you select the stroke, but then you're moving the mouse. Then you're like mastering the mouse. Yeah, I'm really good at the mouse. And then you're just going to draw the path. And this is producing a PDF or an image or whatever that you want, which is containing this kind of curve. The cool thing is that it also has a lot of typographical features like OpenType, because we want to use it as well as a tool to produce our own kind of things, and we want to have high-level support for typography and everything, because we're also type designer and want to use this kind of thing for example, making specimens and booklets and things that has to do with our practice everywhere. Robot is open source. It's robot.com. Get it. Download it, use it, abuse it. There's a very good documentation with a lot of examples. A lot of people are using it. There's a forum which is super active, which is really cool. Maybe then the next step, the craft of coding, is RoboFont. It's my font editor. It's the best font editor ever. You're laughing, but it's true. It's a box of boxes, because the big box of RoboFont is that it can do anything what is required to edit a UFO. UFO is a file format. Everything which is stored inside the UFO file, RoboFont can edit, so you can move points and master your mouse and things. You can edit kerning and the metrics and write OpenType features and whatever. So that's the big box, but actually inside RoboFont, there's like a set of all little boxes that you can use all the time. Present gifts that like, it's there, but I didn't know. It's like, whoa. You can make your own kind of tool. Really important. Start writing coding. So it's kind of like, it helps you to get started, because it's like a big box with little boxes inside, and then you just can play and get started. Little tiny scripts. Don't have to write RoboFont itself. It's also possible. It's also written in Python. I studied graphic design, and I had a master in graphic design. I have a master in type and media, but I never studied programming language or scripting or math or something, but somehow it is kind of something which is very familiar to what I'm doing. So you can one day write RoboFont as kind of a Python kind of application with a lot of boxes, and a lot of people are using it. Another kind of thing where you can learn the craft of coding is just by looking at other men's coding. GitHub is full of coding. A lot of type designers are publishing their codes on GitHub and sharing their kind of scripts. Little tiny things, bigger things, really complex kind of extensions for RoboFont. It's also really kind of nice that you can read all these kind of things. You can add comments. You can also making and starting become a coder. It's also about writing documentation for someone else. It's making issues and how does this work? Why is this not working? And complain nicely. It always helps. But try to look at it. What it does, what it do, and how can I kind of use it? Another kind of thing where you find like direct access to a lot of coding. An example is on Mechanic. Mechanic is an extension for RoboFont that is hosting 100, 120 other kind of extensions where you can just kind of install, but just like have a direct link to all the GitHub repositories, so you can just like download it and look at it again. But maybe again, the smallest scripts are maybe the best script. Everyone can read this. We will ask the current font. We will put it in a variable f. We're going to loop over all the glyphs in that font. We put it in a variable called g. We're going to change the left and the right margin by adding 10. and then you have something that you have to judge, because what you see at the end is really more important than the numbers itself. If you think maybe the spacing is not correct, maybe I have to widen it up or tighten it up, then you just can quickly move with the numbers like a little bit, and then you can look and judge. Is it better, not better? Maybe it should be, I don't know, I print it out, I'm going to pick this one, and then everyone is happy. This may be like a very favorite all-time, I think from a lot of people, an all-time favorite little script. It's 2 lines. We're going to ask for all the open fonts which are open in RoboFont, and we're going to test install it, because then you can use it directly in InDesign and in other kind of places, which is kind of really cool. And to conclude this 30 minutes lecture, your circle is not my circle. This is a quote that I'm doing like a lot with my students as well, to make them frown like a little bit. What is he saying? I think it's really important that you design your own kind of circle. RoboFont, for example, doesn't have a primitive tool which is defining what a circle is inside, so there is an extension for this. But it's already kind of, it's my circle. If I design a circle and put it in RoboFont, then you will draw an eye, a dot on an eye with my circle. And maybe your circle is better, or the circle for that project has to be a different kind of circle. I think it's really, really important that you all question and be very critical on the tools that we are using, that you're not only mastering the mouse and maybe the application or the tool or the computer or the electricity that goes into the computer, but also how you look and perceive kind of things. All right, I'm done.